My name's Sam Lane, and I'm the Director of Sales and Marketing for the SE Shires Company. And you're not going to hear much from me today. I'm going to let my amazing colleagues do what they do best. But this is something that we all feel so passionately about because you guys and gals and the whole community are incredibly important. And so many of our own team members come from a repair background. So much of what we do is communicating with repair techs, and you're really the gateway to the success for musicians everywhere. So we wanted to try to find a way to be a resource or just connect with you. I mean, for a lot of you, maybe some of the things that we show you, it might be the first time you've seen this. Maybe you're coming from a woodwind or like luthier background. For others, some of this might be, you've done it a million times, and at least we can all kind of be in it together. Today's format, we're going to present each one of these sessions on a separate topic, right? So we've got 5 sessions this month. They're all going to be on Wednesdays at noon Eastern. Today, we're going to be covering common component repairs for trombone, and we're specifically going to be focusing on trombone valves for the first half, take a little break for a few questions, and then trombone hand slides for the second half, take a little bit of a break for the last few minutes and questions. Next week, we're going to do trumpet component repairs. The following week, mastering dent work. The week after that, March 24th, approaching solder repairs for trombone. And then the 31st is a similar topic, but with trumpets. All of these will be recorded. So if you can't make a session, no problem. I think what we'll probably do is host the videos on the same site that you registered, just to keep it really easy. If you need access to something, I'll also probably have them in a Google Drive, and I can send you the link to that too. But more than anything, we're so pumped to connect with you all. This is going to be really, really fun for us. If you haven't registered for today's session, you can do so at seshires.com/repair seminar. I'm going to give a little link to that in the chat as well. In addition to registering for the session, I think I'm also going to do a little bit of a raffle for some Shires swag. We have some like fun t-shirts and some Shires pint glasses, which resonates really well with the brass community. So we'll do a few things. I think that'll be really fun. And then, yeah, so then let me just see. In terms of questions, in the format for today, my colleague Kenny is going to be presenting, and my colleague James as well. I would suggest when they're talking, pin their videos to your screen so you can see them nice and big. And when we stop to take questions, what I would say is let's have you ask your question in the chat box. That way we can queue them up and keep an idea on how many questions are coming in, make time for those. If you want to ask your question like live and explain it better than I'll be able to, I'll throw it over and say, hey, it looks like Frank Price has a question. Frank, why don't you go ahead and ask James and Kenny? I think that's probably going to be the easiest way to do it. So just in the chat, let us know that you have a question related to hand slides or straightening tubes or whatever it is, and we'll get it queued up for you. But without further ado, and less chatty chat from me, I'm going to turn it over to my colleague, James Monahan, who's the general manager at SE Shires, and he'll do a nicer job explaining what we're going to be starting to cover today. So just a reminder, feel free to pin his video when he's talking, and when my colleague Kenny's talking, go ahead and pin his video. That way you make sure that you have it nice and big on your screen.
Great, thanks, Sam. Again, I'll just kind of welcome everyone here. It's great to see like so many of you guys, interested in what we're doing here at Shires. Just a little bit of my background. I'm a trombone player. I actually started working here back in 2004. I had come as a trombone customer. I played a Shires trombone and came in for some repair and kind of fell backwards into a career as an instrument maker. But I've been here for 16, 17 years now, working mostly in the back of the shop as a craftsman, and then sort of running the production of the custom instruments here in Holliston. Like Sam said, we're going to basically focus on 2 kind of big topics. First is trombone valves. We make 5 or 6 different types of valve for the trombone. Some of them are very familiar. Some of them are unique to us. They're our own patented designs. So what Kenny's going to do is he's going to walk you through very kind of step-by-step exactly what these valves are and how to work on them. And then at the end, we're going to kick over to me and work in slides. That's kind of where I spent most of my career in slide making. And so we'll kind of show you all the ins and outs of some things that are unique about Shire's hand slides. But then also, you know, some general repair tips and do's and don't do's for those. So I'm going to introduce Kenny Pyatt. He is our repair shop manager. If you have repair questions and you email repair@SEShires, Kenny's the one that's gonna help you guys out. He's a great craftsman here and a really great guy, and he's done a really good job at organizing the repair side of our business. Has been a great asset for him. So Kenny, I'm going to kick over to you and take it away, man.
All right. Hi, everybody. I'm Kenny. As James said, I'm the repair manager here at SEShires. Myself and Paul here. Paul is the assembly and filing manager here at Shires. He is going to be my hands as I show you all some basics about all the different valve sections that we have here at SEShires. So we're going to start with our rotor valve. This particular rotor valve that I have here is our Alessi model. And I want to show you some things about how to disassemble, assemble, and any basic repair things that you might come across when you see Shire's valve sections come across your desk. So the first thing that we do, and we have some, sorry, we don't do that. We have some of these dummy, we call them dummy protectors, and we screw them into the hand slide receiver to keep that from banging around and disturbing or scratching any of the lacquer. We also have some screw-ins that go here to the bell connectors to protect those. We just make sure nothing gets scratched as we're moving the valve around. We also take some painter's tape sometimes and tape those up to keep the lacquer from getting scratched up. So once we have everything screwed in, what we do is we start to take off the linkage on the other side. Paul just has a very small flathead screwdriver, takes off the linkage by unscrewing that. To start to get into the valve. Then we unscrew the stop arm. Large ones back there if you need it. All the time taking pretty good care not to scratch anything, of course. Next is removing the stop arm. Yeah. And the way we pound that out is we have a T-handle here with the threads specific to the threads that correspond with the valve itself. So we screw that into the stop arm. You can also accomplish this if you don't have something that screws into the valve. You can take a small metal rod and put it into the middle of the valve. As long as it doesn't touch the threads itself, you can tap it out that way. Keep your hand under the stop plate, as you can see Paul's doing here, and gently, slowly tap out the valve. You want to really avoid keeping the screw in the rotor itself, because that can both bend the screw and damage the valve, strip the threads. So we have a T-handle that screws straight into the rotor there. Stop arm will slide right off. Stop plate will slide right off, and you're into the valve. So I want to show you the difference between two of our rotors while we have the rotor out here. The rotor that is in our standard rotors and the Alessi model, our new Alessi model, looks like this. It is skeletonized and vented. So it makes it a little bit lighter, makes the action a little bit faster and a little bit smoother. That's our standard rotor. We also have a different rotor called the dual bore. It's named the dual bore because it has two different size bores. That'll look more like your traditional rotor here, so don't be surprised if you see something coming out of a Shire's that looks like a standard versus this skeletonized one. And getting them into the instrument is the same. They're going to be indexed the same. You can see there's a little notch there that the stop arm will slide right into. So once we have the valve out, sometimes you might have valves that come in that are very scratchy, that are binding a little bit. We use for all of our finaling a very, very light non-embedding lapping compound. I think this is 1000 grit.
Yeah.
Very fine compound. Where do you want to put that is a very good thing to know. If you overlap a valve in the wrong places, it can actually make the valve worse. So we'll put a little bit of this compound on the face of the valve here, all around.
Don't want to put it on here.
You do not want to put it on the spindles where Paul's finger is. If that gets lapped too much, it can bind, it can scratch, it can canter, can cause it to move back and forth. And as you know, you can't put metal back on. So you want to be fairly careful where you put the lapping compound there. So that's basically it as far as what you're going to run into with basic repairs for the rotor. Paul's now putting on some valve oil, and we're going to put the valve back into the case. Putting on stop plates for our rotors. Seen a lot of wrong ways to do it. Here's how we do it. All of the stop plates are going to be indexed. So as with, let's see if I can get the camera to focus here. Hopefully you can see the notch in the bearing plate and the notch in the casing. Just line those up. It'll be indexed on the valve as well, so you can double check yourself. We have machined this little device here. It applies even pressure across the bearing plate, and we have a little notch drilled out. Pretty easy to do if you don't have a lathe where you can make this yourself. Any piece of wood where you can just drill a hole through it. That's the size of the bearing plate there. That's good. It goes and fits right on top of there. And then we just hammer it back on. It's important to get even, slow, light pressure onto the bearing plate itself. If it goes in cockeyed, it can cause the casing to warp, and that's a whole different issue that you'll need to fix. So it's important to apply equal and even pressure across the bearing plate there. Okay. So that's our rotor. We do have a different kind of rotor. Our newest valve that we've made is the twin valve. Not a whole lot different here as far as the function of the valve. All it is two smaller rotors. The unique thing about this is it's strung. It moves. We have a diagram for stringing these if you'd like, but as you can see, it's strung just the same as a French horn valve. So get it oriented here. The top valve is strung just like a French horn, and the bottom one is strung the mirror image of a French horn valve. So if anyone would like, we have a diagram for stringing this together. But if you know how to string a French horn valve, then you're good to go for our twin valve. Taking the valves out and putting them back in is a delicate process because this is all brass and the knuckle here is very soft. So Paul will show us how to hold it for tapping out the bearing plate for the twin valve. We also have a special tool that we made for putting the bearing plate back on that we'll show you in a second. I don't think we need to tap it out, just show where to hold it. So the middle knuckle, the connecting knuckle here is very, very soft. So when you're tapping out the valve, you want to hold it on the receiver. So you're not holding one valve.
Just so one valve is in your hand.
Right, so you just want to have one valve in your hand. You don't want to have both valves in your hand there. Otherwise, the valve can bend and it can warp. And straightening out the twin valve is a delicate process. So you want to make sure if you're tapping out this valve, hold it by the receiver, and that valve, if you're tapping out the other valve, flip it around and hold it by the connector on this side. Putting it back in, we made this little guy here. It's the same thing as for our rotors. It's just a little smaller. We can't put this big guy here because it gets in the way of the other valve and you can damage it. So we have a smaller diameter one to fit the exact diameter and circumference of the bearing plate itself. Be very, very careful if a twin valve comes across your desk to get the bearing plate when you're tapping it back in as flush as possible. The threads here are very thin, very delicate. They can warp very easily. Otherwise, repairing the twin valve, doing any lapping or any fitting is exactly the same as our standard rotor. Okay, that's our twin valve. Next, I think we'd like to move on to the true bore, which may look different than many other valves you've seen. The repair on it isn't a whole lot different, but there is one component that is different than any other horn that you might come across. So this is our true bore valve. It is basically a giant rotor, but with one special thing, the stop plate. It may look daunting, but it's okay. I will walk you through it. Tapping out the valve itself, again, you want to be fairly delicate with it because Paul's going to screw in some of our dummy protectors here. There's really not a whole lot of space here between the spindle and the two tubes. So tapping it out, you want to be as delicate as possible. I'll come up top here. So Paul's disconnecting the linkage. For any repairs, we like to take the whole linkage off. Paul's just undoing the second screw here. We're taking the main screw out of the stop arm. Okay. And then we have our T-handle with the threads. Again, if you don't have something like this with the threads in it, you can get a small piece of metal rod to put into the center of the rotor threads, just taking care that the metal rod doesn't strip the threads there, and tap it out that way. So now that we've pushed out the valve, that's what our true bore looks like. Now, the special thing about this is it has a hex screw right in the middle of it. And what that does is that helps to index and align the valve in accordance to the stop plate, which also serves as the bearing plate. Show the face of it. And every true bore valve will come with pre-cut bumpers. If you do get a Shire's true bore, there is no need to replace the bumpers unless they're dry, cracked, or missing. They are already pre-aligned, pre-cut, pre-measured so that the valve is in perfect alignment with the valve casing. So if you have a repair where you're lapping the valve or cleaning it out, putting the valve back in should be fairly easy. Almost 100% of true bore valves will be indexed for easy replacement. They will be marked the same as our rotor with a notch in the casing here. That lines up with the stop plate and bearing plate. So it's just the same as putting it on. The pin here will be on the inside of the rotor. Okay. Fairly easy process. And then tapping the bearing plate back on as evenly as possible. Now, I have gotten a few emails of people who have gotten true bores in where there is no index. And I will show you, Paul and I will show you how to line up the true bore if it's not indexed.
You'll want to put the stop arm on.
Okay.
So you have something to kind of grab onto.
So Paul recommends that we put the stop arm on first. And then you'll take a flashlight and let me see if I can actually turn my phone flashlight on so we can see to the valve. So if you look down, into the valve, if it's open, you should be able to see all the way through. Okay, and if you're replacing the bumpers, it should look like that if it's open. So you can align the first bumper that way. And the valve open, the pin is going to be away from the hand slide receiver. Okay, so this is valve open. You'll be able to see straight through. And you'll be able to see the edges of the valve aligning with the ports perfectly there. If it's closed, the pin is closest to the hand slide receiver. You're not going to be able to see anything. Okay. So you want to align first this way with the pin away from the hand slide receiver as such. All right, so that is our true bore. Next is axial valve. This is our version of the axial. I know a lot of people call it the Thayer, which was the original design of this. Our valve construction for our axial is a little bit different than some other manufacturers. There's a lot of different kinds. Let me just grab one so I can show you. Ours are brass valves, brass cones. They are nickel plated. So you can see we have a brass tube. and the valve itself is nickel plated. Some Thayer valves, you'll see it's kind of skeletonized. We're missing, looks like we're missing half of the valve. Some, our Q series, for instance, the valves are stainless steel. But all of our customs, they are brass cones, nickel plated. And Paul's going to take apart our axial. So as always, we put the dummies on to protect the threads, to protect the lacquer. Moving the linkage. Now, for me, always one of the most frustrating parts of getting an axial apart is how to go about taking off the stop arm. So we have a special tool for this. First, we have a large flathead screwdriver to take off the center screw that goes right into the valve itself. And that allows us we get the screw out fully. That allows us to use these super high-tech pair of equipment. Basically what this is just some small duckbill pliers. And we have brazed, get my camera to focus here. We've brazed a little pin on one end that will fit inside the stop arm. And we have carved out a little area that will fit around the spindle of the valve. So we come in this way to the valve. Just show them on that, and then we'll do it. So it comes into the valve this way, and we push down that way. So that's the X-ray version. On the valve itself, going slowly, and squeeze down, and the stop arm pops off. They work really well. It's easy to make at home with solder. So those are our little stop arm removers. It can work on rotors. It doesn't always fit perfectly, and sometimes the rotor stop arms are cinched down a little too much where you can't get the bottom part of the pliers in smoothly. But for axials, they work really, really well. I'm taking apart our axial. Make sure you unscrew all of the removable screws here and unscrew the ring on the axial and slowly work the valve back and forth, slowly, gently, and the top will pop right off. I get a lot of axial repairs because people think that the valve is dented or broken or something is wrong with it. Most of the time, it's just a cleaning issue. The basic cleaning that we go through, we have ultrasonic tanks here at the shop, but any solvent that you like to use will take away a lot of the crud. You're not going to hurt the inside of the valve. You're not going to hurt the valve itself. Just want to be careful of the lacquer. So any cleaning process that you use for these is fine. What we do once we have the valve cleaned and dry is we do a micro meshing process. Micro mesh, for those of you who may not know, is just a fine, very fine grit sandpaper, but it's on cloth. And the grits that we use, once everything is dry, is we take 2400 and gently rub, micromesh the valve. We like to go in the direction that the valve spins to make sure everything's as smooth as possible. So we'll go over the valve with 2400, with 4000, and then 6000. So we'll do that on the valve. We'll do that on the casing here. And we have a granite block that we'll put a square of the micro mesh on, and we do a circular motion with the top plate here on a perfectly flat granite block to make sure that this valve is completely level. Because the only parts that contact for our axial valve is, you can see there's a little line, a little strip where the valve will contact the casing itself here, and it will contact gently the top of the valve to the top plate. So if you do have a valve that needs a little bit more than cleaning, we will use some of this very fine grit, non-embedding lapping compound, and we'll put a little bit on that little strip of contact point there, and a little bit on the top of the valve.
Gel.
You can use slide gel to lubricate the lapping compound, so it's
Put it on the spindles so lapping compound doesn't.
or we like to use sperm oil to lubricate the lapping compound itself. What you don't want to do is get any of the lapping compound on the spindle. An overlapped axial spindle will cause the valve to canter, cause it to bind, cause it to scratch. And again, as you know, we can't put metal back on. So what you can do is put some grease, some tuning slide grease, some sort of thick, heavy oil on the spindle here to keep the lapping compound from getting onto the spindle. Okay. So that is how to take apart, how to lap, how to clean our axial flow valve. Putting it back together is just the reverse of taking it apart.
So these are tightened.
What you want to do is make sure that these are tightened first. The tuning slide outer connects are screwed down first. That helps align the valve to make sure that the top plate is parallel with the casing. If you try to put things together without the component being perfectly parallel and solid, can run into issues with the valve binding, scratching, causing things to go out of parallel. Stop plate goes back on. We have two different kinds of stop plates that you'll come across. Our current one, or stop arms, excuse me. Our current ones look like this, and it's a circle with a little flat edge on the side of it. Okay, that's our current generation of stop arms. Hopefully, mostly what you'll see is this. Our older instruments will have this. Yeah, my camera focus. This has a little pin in it instead of the flat edge. When you see these, be very careful with these. We switched from this design to the new design because this pin is very delicate. They pop out, they break. They're very, very difficult to get back into alignment with the valve. But we do have some of these that we can provide or reverse engineer if you do find yourself with an older Shires with the axial stop arm with the pin in it. We can help you out with that. But hopefully, mostly what you'll see is the stop arm with the little flat edge there for our axials. One last quick thing about the axials is what to do with the bumpers. Okay, there's two bumpers here with all axials. Aligning them is very easy. All you want to do is look down the, if I can get it here in the camera, but you can look down the long tube of the axial and you'll be able to see the valve this way. And if you see any little edge, you can trim the bumper a little farther if you need to go one direction, or stick a new bumper in, and don't trim it so much. As far as basic valve repair, that's all of our valve sections. We have bass trombone versions of our axials, of our rotors, of our true bores. Those are just the same as doing the tenor version of them. There's just an additional valve, just like any other trombone manufacturer. So that is basic component repair for valves that I have for you. I think we want to open it up for questions on the valve section. Awesome.
Let me just throw a couple at the team for Kenny, Paul, James, whoever wants to grab it. One that came in, and it's nice and like accessible for everybody. What oils and tuning slide greases do we prefer to use, and why? So what do you suggest there? And then one specific thing is, do you want to lube the pin on the rotor?
Great. So I'll start with what oils we use. We have, turn my camera around. So at each workstation, we'll have something like this, where we have large tubs and large containers of Hetman. Almost everything we use is Hetman oil, Hetman slide grease. For our axials, for our rotors, it's almost all light tuning slide or light rotor oil for Hetman. I don't know the number. Do you know the number, Paul, offhand?
I will also say too, we have a little care and feeding document that I'll make available on the same page, scshires.com/repair seminar. So I'll have all of these videos live there, but we'll also give you guys some additional resources for the oils and lubricants and all that kind of stuff.
Yeah. So what we use on the trombones, for all of the moving parts, the valves, we use light rotor oil, and then we'll use different thicknesses and different viscosities of the tuning slide grease. So we have light slide grease. We have heavy slide grease that we use. For the large tuning slides, we'll use, I think 7 is the heavy slide. We like to use that. That's good. It doesn't tend to leak too badly into the casings, because oftentimes if the tuning slide grease gets too diluted, it can move into the valves, and that can cause you gumming up. The Hetman tends to stay in place pretty well. So we like to use that on both our trombones and our trumpets. The trumpet valve oil that we use right now in the shop is 5-star. We really like that. But as far as our trombones go, any of the Hetman works fantastically. The second question, I think, was oiling the spindles. Was that correct? Oiling the stems?
Yeah, where did it go? Yeah, Joe Hoffman wanted to know, would you want to lube the pin on the rotor?
Do you want to lube the pin on the rotor? The spindle or the screw?
Joe, maybe you
I'm
can
wondering. So we do put a little bit thicker oil on. We use I think ball joint on. We can use ball joint or bearing and linkage oil on
Joe
the spindles.
Said for the true bore specifically.
For the true bore, oiling the pin, the alignment pin. That's probably the question. We don't. That'll screw in and stay in place and come out easy enough without any lubrication. So we don't do anything with the alignment pin in the valve itself. But yeah.
Okay, cool. Last question, and maybe we can spend some time talking about this in one of the next sessions as well. We had a couple questions just about the twin valve design. But then also you were mentioning how delicate the knuckle is on the twin valve. So
absolutely,
why do we not reinforce the knuckle on the twin valve? But also, what's the benefit of the 2 smaller rotors? So maybe take a short little stab at the question, and then we can also save time at the end after we get through slides to keep talking about it.
Yeah. So let me switch over my camera to the twin valve real quick. The reinforcing of the knuckle here is probably an R&D question that is a little bit above my station. I'm not sure, but with a lot of our instruments, if there's too much bracing, if there's too much metal in certain points, they tend to play a little deader or heavier. So that may have been a playability design decision. And what was the second part of that question, Sam?
Just why we have a twin valve. What's the benefit of the two rotors and the way that, why do we do it?
So Sam, this is James. I can jump here.
Thanks, James.
And talk a little bit about this. Benefits of a twin valve. There's actually two. One is an attempt to get light, basically add lightness to the instrument. Having two very small valves, the two valves together weigh actually less than our traditional rotary valve. So it's a way to get weight out of the instrument. Also, the smaller valves have less rotational mass. So it actually takes a lot less energy to get the valves to rotate. Think about like a figure skater doing one of those spin things on the ice, right? When they pull their arms in tight, they're going to spin around really quickly. They spread their arms out, they're going to spin around slowly. Having a nice, very small valve has a lot less rotational mass. So it's going to spin faster. It's actually going to take a lot less effort to get the valve to move in both directions, even with two of them ganged together this way. We actually have a special lever and set the springs lighter on the twin valve than we do on our traditional rotary valve or our Thayer valve to get them to feel like they have the same pull. Also, having two valves, each with only 3 ports, there's only one pathway through the rotor as opposed to on a twin valve, as opposed to a standard rotor, which has 2 pathways, one for the exit and one for the return back into the valve. With only one pathway, the deflection, the angle of deflection inside the rotor is a lot less. So actually the path through both rotors is straighter and truer than it is on a single traditional rotary valve. So those two aspects, lighter weight, more open feel, and quicker, lighter action. Those are the benefits of that twin valve.
Thank you.
Sure.
So we had another quick question, which I think we'll save for the end so we can move on to slides, just about restringing. I just commented back that we do have a diagram for this that we'll make available to everybody, and we'll save that for the end. That way we can get through some slide stuff. And then if anybody else wants to stick around for more questions, feel free. So.
Yeah, and one of the things I think we will probably end up producing would be a slide or a twin valve stringing video hosted by Kenny, who is our expert at this. And he'll basically show the whole process. Oh, I'm putting him on the spot. Show it kind of in a nice in-depth video just for that one topic, because that is unique to our valve. It's the same concept as stringing a French horn valve, which is also one of those things that we all kind of need to know. And if you can string a twin valve, French horns will be easy after that.
Super. Yeah, so we'll keep you guys posted on that. We'll make the diagram available, and we'll be sure to follow up, and maybe we'll add another one of these sessions, invite y'all to it and record it or something. So
great.
Cool. Go ahead, James.
All right. So I'm going to head over to slide land here. I'm here with my colleague, Sean, who is in charge of our hand slide department. There he is. I'm going to kind of go through our kind of like most, biggest topics here in slide filing. I'm going to hand the camera over to Sean because I'm going to demonstrate a few things here. There I am.
There we go.
All right. So first thing that is unique to Shire's hand slides is our interchangeable modular lead pipes. So the lead pipes on a Shire's trombone are removable and thread into a receiver in the top of the hand slide. Often after someone has been playing a slide for several months, every time you put the mouthpiece in, twist it to the right to seat it down, the user is basically going to cinch this screw down tight to where it cannot be removed. And that's one of the first things that anybody working on a Shire slide is going to need to know how to do safely. I've seen a lot of slides come back from customers with gouge marks on top of here because they've gone after it with channel lock pliers. There's 7 things you can try before that. I'm going to show you the best of 3. First thing that I do when I mat with a stuck hand slide is I'll do just the trick of putting a mouthpiece in to give me a little bit more kind of purchase and a little more mechanical advantage. So cinch a mouthpiece down in there, and then I'll kind of push the mouthpiece into the lead pipe and try to unscrew it that way. If you can get the lead pipe to start unscrewing, it's a really good sign. course, now you've probably got your mouthpiece stuck in the lead pipe. The best way to get the mouthpiece unstuck at this point is two things I'll do. The first is this kind of trade show technique that I used when I'm at a trombone festival. I'll just grab the mouthpiece, in my palm as tightly as possible. And I end up just kind of squeezing and shaking it back and forth. And what you do as you're squeezing it, it actually puts kind of like direct pressure up on the mouthpiece. And that 9 times out of 10, it'll pop the mouthpiece out of the receiver. You're basically turning your hand into a mouthpiece boiler at that point. If that doesn't work, I always carry an actual mouthpiece puller. This is, I think I got this from Farees. It's kind of just a standard mouthpiece puller. It's got the little wedges on the back side. It's got 2 screws that kind of like expand the mouthpiece out. These work great, and I really highly recommend them. What you don't want to do is start banging on the slide and banging on the lead pipe with like a rawhide mouth. That can actually, if you bang hard enough, it can actually start bending, putting torque on the tubes inside the slide, and you'll actually start creating more problems than you're solving. So that's the first way of getting lead pipe out and getting the mouthpiece unstuck after that. Second thing we've done is, I'm going to shameless plug for the bionic wrench. This is something that initially my mother-in-law bought me for Christmas off of like QVC because she thought it was cool. It's like the best tool that we have here. There's like a dozen of them around the shop now. It's basically designed to be sort of like a ratchet, a socket wrench that will fit any size hexagonal socket. We use it as a mouthpiece puller. So basically you can come in and grab the collar of the mouth pipe without hitting the collar underneath and without putting gouge marks. It kind of grabs it from 6 sides, gives you a lot of purchase on that, and then you can usually unscrew it from there. That's kind of the best way of getting the lead pipes out. And if you don't have one of these, grab one for your shop, because it's a great product. And it's really handy for getting any sort of tube unstuck from something. It's a great way to grab stuff. Cool. We're going to show you the next thing that's a little bit unique to hand slides, Shire's hand slides. And that's the felts that we use inside cork barrels. I'm going to show you exactly what we use for felt and how to safely remove those felts, because it's a little tricky on a Shire slide. I'm going to grab the phone back from Sean. Sean's going to show us the stuff. So first of all, the felts that we use, a lot of companies will use like a pre-printed like green felt disc that they'll stack several layers high. I never liked those. We actually use just sheets of felt that we cut into strips. So any slide will have basically one piece of felt in a strip underneath the cork barrel. Our felts are about 2 inches long, about a 1/4 inch wide. That's the material that we cut. Thickness is also, I'm not exactly sure how thick this is, but we'll put it in the document Sam's going to have, kind of like a part number for this material. The felts are installed basically as a strip around the tube. So we'll kind of like set the felt around the tube. There's always going to be a little gap, which actually is going to make it easier to extract later. And then we'll kind of like seat it down into the cork barrel. To get the felts out, we have made out of a junk tube these nice little like corkscrew grabber things. It's basically a tube, and we'll cut kind of a corkscrew and a point at the end. We'll go down into the cork barrel and kind of twist around and try to grab a corner of that felt and just drag it right out. Takes a little bit of patience, and you kind of have to whittle at it slightly, but eventually you'll grab a corner of it and pull the strip out. These last for years at a time. They're not dyed like those green felts, so you're not going to get like moisture in there, making kind of leaching out that green dye. A lot of times, a lot of other makers will have a tinted felt that will kind of start to get funky in there. These are just undyed felt, very clean, very long lasting. Good job. There you go. All right, I'm gonna look at my notes. So, basics on hand slide function and repair. A slide basically needs three things to work properly. It needs to be smooth and clean. It needs to be to have straight tubes, and all those tubes need to be parallel with themselves. And if you have all those things, the slide should work well. I'm going to show you basically our technique for each of these three steps. The first being cleaning. Back to Sean. So in our process, making new slides, we build the slide, do some internal honing on the slide, buff and lacquer it, do some polishing on the inside of the outer slide, and then a tremendous amount of cleaning. We start with a, essentially what is a swab. We use long strips of muslin. It's a, basically kind of garbage cloth they use for insides of jackets and stuff. Pretty inexpensive. We'll use, basically almost a yard long, probably 2.5 inch strip on a cleaning rod here. The solvent that we use is Lacquer Thinner. This brand of Lacquer Thinner is great. It's a low VOC clean product. It's a great solvent. It doesn't actually damage the lacquer on the instrument unless you're soaking it in there, but it does do a really good job of pulling grease out. And so we really like this product. It's aggressive enough to pull the grease out. It doesn't damage the material of the slide, and it evaporates clean. It doesn't leave behind a residue or a film. It's a little hard to get in the state of California, as it turns out, but elsewhere in the country, it's actually pretty easy to get. You can order this stuff on Amazon. That's the clean strip green Lacquer Thinner. So here Sean's demonstrating swabbing a slide. We tend to wrap the swab pretty tight in the outer. You want to get it tight enough that it's actually pulling and dragging the dirt out with it without getting stuck in the tube itself. We also tend to concentrate more on pulling the swab out of the slide as opposed to kind of ramming it back and forth and back in and out aggressively. Obviously, one of the things you want to be really careful about is inserting the swab too far into the slide and spiking the crook. I'm going to kind of zoom in and show exactly how Sean is going to wrap this around the swab. So what we've done, here, stop there. We have, folded that 1.5 inch strip in half with the folded edge on the outside, the open edge on the inside. He stuck a corner through the slot of our cleaning rod. And go ahead. Now he's just going to wrap the whole thing nice and tight, nice and organized. He's got a really good feel for how much he's got to wrap it before it's going to get too tight. So let's show that again. So what you've done is basically you get enough rotations around there. He's going to grab inside the fold on one of these and flip the outside over and across. So that gives him a nicely tight kind of like bound swab. It's not going to unravel itself as he's cleaning. We've got these nice little dauber things here. It's kind of like what if you go to get your nails done, they have these same things for acetone. We get big ones for administering the stuff. They're great to have. Kind of speeds up that whole process. So here you can basically see a little bit of twisting and a lot of kind of just pulling the dirt out of the slide. So that's basically the cleaning part of hand slides. We'll do this process. We'll spend, 20 minutes per slide. Yeah, 10 to 15 minutes swabbing a slide before we finish putting it together with the slider mix and sending it on its way. The second thing I'm going to cover is straight. So straightening the slide is kind of an important thing in this whole process. So our process here, we have a kind of standard surface block for straightening slides. It's something you can get from most repair providers. Pretty easy fluorescent light behind the block gives you good contrast, so you can see kind of where the slide is touching the block, where the slide isn't touching the block. So here, what Sean is seeing is he's looking to find any gaps here between the slide and the block. You're always going to see little tiny variations from buffing and little tiny bends. We're really looking for big catastrophic bends that look pretty severe. This slide is remarkably straight. It's pretty good. So pretending there's a bend, basically what we're going to do is we're going to try to discover where the tube is straight, where it's bent, and then make very small corrections. My biggest advice for slide straightening is it's a lot like whittling. You want to make sure you're making very small, quick corrections without doing movements that are way too big. We tend to use a couple different techniques here. Either you can see using a block here where Sean can actually kind of use the block in a hand to kind of put pressure on the slide. A few easy, quick corrections, and then check his work after that. I see we are almost out of time. I think I've hit the kind of big topics and slides.
Were you gonna talk about inner outer spacing and parallel?
Yeah, so we'll demonstrate that real quick.
Okay, cool.
I'm gonna hand Sean the camera. And do you have calipers here? There we go. So the last thing about making slides work is parallel. So it's really important that the tubes are parallel with each other. And the best way of measuring that is with a set of calipers. We use digital calipers here in the shop. And basically what you want to do is you want to take a measurement in between the outer slides here at the crook, and then again here at the top of the brace. So what I'll do is I'll come in and very carefully, without scratching the finish, take a measurement inside here. And because I suck at math, I'm going to actually zero the calipers here, and then take another measurement at the top. And that'll tell me the difference. So this slide is 1/1000th of an inch more narrow at the top of the slide than it is at the bottom. So to give you a little bit of perspective, a sheet of paper is 5/1000th of an inch thick. So this is incredibly parallel. Here at Shires, we build our slides to be within 2/1000ths of an inch parallel, top to bottom. On a good day, we can hit that number within 1. So this is an incredibly parallel slide. If you're getting a slide that's measuring anything over like 7 or 8 thou, that's when things are going to be more difficult to make work. You can still get a slide to work if it's 7/1000ths out of parallel, but it's harder to do. If you see a slide that's upwards of 12 to 15,000ths out of parallel, you're going to need to rebuild that slide. Or if it's a Shire slide, send it back to us, because we would hopefully never let it leave the factory more than 2 thou out of parallel. The last thing that I'm going to cover is spacing between the inner and the outer. Do you have the inner for this one? Yep. Okay. Real quick, 2 types of spacing we have to check. One is the toe, which is basically, do the ends of the top of the slide line up with the outer? So basically, you can just kind of do this by eye, where you hold the slides, make sure that the tubes are both kind of in the center of the outer here at the end. If they're not, you can do a little bit of adjustment. The best way to do that is actually to just, with your thumbs and your hands on the cork barrel here, either push in with your palms. If it's too wide, you can actually compress it a little bit here, or you can pull out by kind of pushing in with your thumbs and pulling out with your fingers here to kind of spread these out a little bit. You can move the slide, before it's really going to break, probably about half the diameter of the tube. So if you've got a slide that's out of parallel and, of course, if it looks about like this, you can probably correct it just by putting that little bit of pressure on the top here. If you're really out of whack, then you're probably safer actually unsoldering something and rebuilding. The last little bit of advice is you want to make sure that the inner is centered in the outer at the top of the slide. Just like you're checking the toe at the bottom, you also need to have these 2 tubes centered in the outer up at the top. And that'll tell you if this inner assembly has been built too wide or too narrow. There's a couple ways of doing this. The best is just to kind of leave the slide extended where you can see the clearance between the tubes, and just visually look and make sure that both tubes are kind of situated in the center of these outers. If you see this tube is kind of feeling like it's in the center, and this one is jammed all the way up against the outside, the inner's too wide. If it looks like it's jammed up against the inside, it's too narrow. You can also kind of hold the slide neutral on one side and just give this a little wiggle back and forth this way. You can actually feel how much clearance is there. If that feels like there's a lot of clearance back and forth here, I'll push the assembly this way. Now this tube is jammed up against the side. This tube should also be jammed up against the side, no wiggle. If I pull it back that way, same thing. Both tubes should get jammed up against the other side of the slide. No wiggle. I'm confident that the slide is parallel within its outer.
Super.
And that is hand slides in a nutshell.
So a couple questions that came in real quick.
Take that.
Why do we prefer our own felt strips versus the ring-shaped ones? Which I think you addressed a little bit, but maybe just another clarification.
Yeah, the ring felts tend to be they're almost never the right thickness, so you have to stack. I see companies stacking 3 or 4 of those together. It just makes it a lot harder to get out. And this kind of unbleached material is cleaner and just a lot easier to use. And it's easier for us to use and get the fit perfect. And also it's great to be able to remove them easily. So it's kind of I think it's a better product, and it's better for longevity and for repair techs.
Cool. The other question, while you were talking about swabbing slides and stuff, why not use the ultrasonic to clean the slide?
We do as well. So the swab is something that anybody in any shop can do. What we'll do is we'll do an ultrasonic wash first, and then do a swab at the very end. So we actually do both here at Shires.
Cool. There were a couple other questions. If anybody else has any other questions they want to throw into the chat specifically about slides, we'll be sure to get to those. I know it's about that hour time, so if people have to jet, that's totally great. We'll stay on here and go through a few more of these questions, so please feel free to stay with us if you'd like to. Our next session is going to be Wednesday of next week at 12 p.m. Eastern, and that one is going to be about trumpet component repairs. We'll do it in the same kind of format as what we did today. Same Zoom link, so you can bookmark the Zoom link. It should all work for you. In the meantime, if you are logging off now, if there are any other questions that come up, I'll put it back in the chat here again, but you can email at repair@seshires.com. After today's session, I'm going to do a little bit of editing to make this video look a little bit prettier for you, but I'm going to put it back up on seshires.com/repair seminar. So you can access that video. And I'll try to grab some more of our documents that we make available to dealers and repair techs for like care and feeding and some other common things. I'm sure this is making all of us here at the shop really excited to have you guys here and to chat with you. So I'm sure we'll put together as many resources as we can, and we'll try to have this as like a hub for you to be able to have access to information about Shires related things. But for now, James, just a couple more questions for you and or Kenny. Let's see. So this was from Jake saying, while we were talking about back to valves, Kenny briefly mentioned using an undersized rod to push out the true bore, but he believed that the stem was hollow on those, and an undersized rod would push through, potentially denting or poking through. Is that true, or where? Let me just see.
So yeah, so I guess my recommendation there is, so we use these threaded drifts basically. It's a threaded stem that goes into that stem. The stems are threaded to accept that rotor screw. If you're using something to push the valve through, you want to make sure that the body of that threaded stem is smaller than the chimney spindle hole of the casing itself, because you don't want that drift to then deform the top of the casing as well. But you also don't want to make it so small that it goes down into the threads, because you're right, you can mar those threads. So it's one of those things where we're having that tool, taking the time to make that tool makes all the difference in the world. It's basically, you know, a rotor screw threads with a bit of cylindrical section, giving you a little bit of purchase around those knuckles that are coming out of the top of the valve.
Oh, and Nathan said, I think he was worried about puncturing into the rotor itself.
Well, the spindle on the true bore valve itself is quite tall. You would have to, you know, go down almost a full inch to actually puncture the tubes on the top of the valve. I can't imagine that would be a problem.
Okay. Do you want to maybe just mention too, because this is something I think we're going to talk about in one of our sessions, but where you feel like if a repair might reach a point where we'd want to take a look at it here or communicate with a tech about the process?
Yes. Can you see and hear me? I'm back on.
Yes. So Kenny's chatting.
Great.
So if you guys want to pin his video.
Yeah. So I'm always available. I'm here Monday through Friday. You can, if you have any questions at all about process, technique, what to do, anything, you can reach me at the email address we shared, repair@seshires.com. Or if you just go to seshires.com/repair, there's a contact form there, and that goes straight to me. So at any point, if you have any questions, please contact me. You can also reach me at the shop. I have an extension here. If you just give the shop a call, you can follow through the menu and get my information. 415.
Thank you.
415 is my extension. Yep.
Let's all spam Kenny with a million phone calls.
Please do.
Emails.
Yes, absolutely. So yeah, don't be shy about giving us a call, sending me an email if you have any questions, or even if you just want to double check anything, make sure that you're doing something properly. Send me pictures. Give me a buzz on the telephone. I'll help you as best as I can. And if it does turn out that there's something that might be better served us doing here because of the specific tooling that we have, or if it's a part that you need, we can talk about that on each individual basis. So.
Cool. Another question just came in. Do we check the straightness of the inner tube, and how do you work with the bending of the material of the inner slide tube? Any techniques?
Yeah, we do check the straightness of the inner tubes as well. It's kind of harder to show in this format, but it's essentially the same technique. So we'll basically lay the inner slide on that same straightening block, and what I'll do is I'll I think he's talking about the stocking at the ends of the slides. It's a wider outside diameter. The tube gets wider at the top. So basically, what I'll do is I'll check the body of the tube, everything up to that stocking, and kind of just hang the stocking off the end of the block. Check the tube around, make sure it's straight, correct any big bends that I see. Then what I'll do is I'll actually slide the inner, to the left so that the stocking is up on the slide. Let's see if I can show this here. Grab an inner, flip the camera around. Whoop. So here is, and yeah, Sean's going to be the hands. So the edge of the stocking here, let me just kind of zoom in and see if I can see, just leave it up like that. So you'll see, there we go, kind of a big gap on the edge of the slide. And then here's the transition onto the stocking. And I should see basically, touching here, and then a pretty even graduation of having clearance on this side. Here I can see it's actually touching there. This stocking's got a little bit of a bend down this way. This is something we would correct. Then what I'll do is I'll rotate the slide this way and see if that shape stays the same or if it gets worse in one direction. All right, so here you can see now there's a big gap at the end and touching at the bottom. Rotate it around. Now it's touching at the bottom and touching over here. So this stocking is a bent a little bit this direction. So what we would do is figure out which way we want to make the correction. Come over here to the block. Go ahead. And then Sean would kind of have the stocking up here supported, and then make a correction this way, putting pressure right on the joint between the body of the tube and the stocking. In general, when we're building the slides, we straighten the tubes right after they're produced, right after they're drawn. We then sand and buff them. We'll straighten them a second time before we color buff and send them out to chrome plating. The tubes are then straightened a third time after they get back from chrome plating, just to make sure that they're straight, and then we'll build the slide out of them. Sean will check the straightness for a fourth time in the filing department and do any other corrections that may have, either we've missed something or a tube got a little bit of extra pressure in buffing or building and it went out of alignment. So the straightness of the tubes is something that absolutely makes a really big difference on the function of the slide, and we do everything we can to add that process into our manufacturing at various steps along the way.
Slides are important. Awesome. Duly noted for trombone. Perfect. Couple things that came in. Number one, and this is something that I'm now wondering because it's super interesting, but do we offer any of the plugs or tools or fixtures or whatever available for sale? Would we be willing to make stuff up to fit our instruments?
So we haven't in the past. It's
right.
we are taking advantage of us having been forced to learning all this new kind of like video conferencing technology to offer even this repair class for the first time. But it is something that we absolutely could consider. One of the things that we're doing here at Shires is we're always growing. We're always trying to improve efficiency. And like one of the big projects that's happening this year is an expansion to our building. We actually just moved into this facility about 3 years ago, actually exactly 3 years ago, last week. And we've already essentially outgrown it. Take a quick kind of pan
and
around
just one quick thing while you're talking. I will say, if you go back onto scshires.com/repair seminar, I linked a couple videos in case you're interested in seeing more. One is kind of a like mini docu thing about the company, and the other one's a factory tour that we did on our Shires TV series. So if you want to see more of that kind of stuff, I put those there. They're really, really easy. We do have other resources, and maybe we can add another session where we just do a factory tour for you with a repair tech focus. I think that could be really fun and really interesting. So maybe we'll add more sessions to our lineup. But James, I think you were gonna do something.
So I mean, one of the things we're doing is we are expanding another 8,000 square feet to our building, and investing in some new CNC equipment as well, which actually would increase our capacity to offer some of these, like some of the drifts and tools that we're using on these rotor valves. So it's definitely something that we would, I'm gonna take my mask off now that I'm in my office. Something that we would be interested in offering, and especially if there's demand for it. So I think that's a great idea.
Yeah, for now, if there is something that you find that would be interesting or helpful for you, feel free to email us at repair@scshires.com. At least that way we can get a pretty good gauge for who's interested in what we can follow up with you when we get to the point where we can do that. Another question that came in from Nick, and I love this idea, and this is kind of what we were thinking. We thought that these repair seminars, even though it's kind of like a webinar and you're not necessarily participating, would be a nice place to start. We'll cover a range of topics. And then for some people who are interested in doing more, we could book one-on-one sessions with you in your shop, or we can do smaller breakout groups or something. Nick's specific question was, do you think there's a possibility to have on-site workshops, maybe once COVID dies down more, where we could not only see how you work, but also try some of your methods? We talked about doing some of that stuff in person, obviously before COVID. Now with this technology available, there's a fair amount that we can do, even if it is on a more one-on-one basis. So if you work for a music store and there's a group of repair techs and you all want to work with James and Kenny and Sean on XYZ, then I know that we'd be really thrilled to set that up for you. After we complete these seminars in March, I think we can start scheduling some stuff out at that point. So the best thing to do would be to reach out to us at repair@scshires.com and let us know what you're interested in, and we can kind of take it from there. Let me see. We had another question. James, are you and Kenny still good for a few minutes? I know the shop's buzzing again, but
yeah, absolutely.
Okay, cool. So Aaron wanted to know, do you also light sight the slides to check for straightness, or do you only use the block? Using the block seems to be more time consuming while getting the same result, no?
We only use the block. It's using a light to sight the straightness of a tube is quick and fairly accurate. We've always used the straightening blocks here because I feel like you get a little bit better resolution. You can see smaller things, and with as much tube straightening as we do here, we've gotten very fast at it, and it's kind of our most comfortable way of doing it.
Cool, awesome. Let me see. So far, I think those are the only, I'm just going back through the chat really quick just to make sure. I think so far those are the only other questions that we've had during this session. If anybody else has anything, feel free to pop into the chat. James, Kenny, is there anything else that you want to address based on today, or what do you think? Otherwise, you're good.
Yeah, I know we kind of breezed through a lot of the valve sections, and it was very, very basic. For if there's interest for one of the other sessions, maybe the next trombone session, if there's interest, I can actually go through and lap a valve. We can go through that process, go through an actual repair that we do. Dent work is a separate thing, and we have an individual session on all the dent work. So we'll cover anything like if there's someone bonked their rotor, or maybe a top plate is a little bit out of parallel, we can cover that in the dent repair. But yeah, if there's interest, we can actually go through lapping a valve. If it's completely bound and it's not moving, if there's scratching, any sort of thing like that. For the valve section session, I just wanted to make sure that we kind of looked at some of the more uncommon valve sections that may not come across your bench super regularly.
Awesome.
But yeah, if there's interest, we can absolutely go through repair. And I think, Sam, you said we'll have some more in-depth, high-quality standalone videos for certain repairs and components. So
yeah, our big goal here is to make ourselves as available and accessible to the repair community as possible, because we're all kindred spirits and we all want musicians to have equipment that it's a joy for them to play on. So the work that you all do is incredibly important, and if we can be a small piece of that to make it helpful for you, that's ideally what we want. So we have some of these seminars already scheduled out through March. Like Kenny's saying, we have no problem. We can add more. We can do other topics. We're planning on doing additional video content. And I'll basically make like a landing page for all of you to have access to all of this information. So you can go to one place for anything Shires brass related. And obviously some of this carries over to non-Shires, which is great, better for the brass community. But if there's something that we didn't cover that you'd like for us to cover, again, repair@scshires.com, shoot us an email, let us know. Trying to think if there was anything else, but otherwise, next week we're going to start talking about some trumpet stuff. The following week is going to be mastering dent work with Chuck Shepard, who is absolutely incredible, and he's been with our company literally since day one, but he's an incredibly accomplished repair technician and pretty legendary. So having him do the dent work stuff is going to be fun for all of us. And then we'll get back into trombone and trumpet repairs for the last 2 sessions in March. But yeah, I'll edit this up and I'll put it on the scshires.com/repair seminar page and just kind of keep adding videos there. But please reach out and let us know if there's anything in particular, or comments, questions, concerns, praise, all of it. Just reach out and we'll be happy to hear from you. So cool. Awesome. Well, thank you everybody for joining. This has been great.